Good morning, everyone. We are Team Nitish RG.8220 PSGPS 2020, and our project is RailMInd. RailMInd is an intelligent railway operations platform designed to help manage railway accidents, operational tasks, maintenance activities, and critical decisions through one unified system. Railway networks generate a huge amount of operational information from delays and maintenance issues to incidents. The challenge is not only identifying these problems, but understanding their importance and making sure the right person takes the action at the right time. So, our workflow is simple. Basically, the agent will first detect, then analyze, and after that, it will prioritize, and then he will assign, and then after assigning, the person will act and then resolve the problem. A railway event is detected, analyzed, and prioritized. If action is required, it becomes an operational task. The admin then assigns the task to the appropriate team. The team takes action, and the status eventually moves towards the resolution. Now, I'll quickly show you how this workflow actually works inside RailMInd. I'll start by logging in as an admin. So, our RailMind has four roles: admin, maintenance, operations, and station manager. And each role gets an experience based on its responsibilities. This is the admin dashboard, the central control point of the RailMind. Here, the admin gets an overall view of the current railway operations, including active tasks, incidents, approvals, and important operational updates. The dashboard is designed to give the admin a quick understanding of what's happening across the system without overwhelming them with unnecessary information. We'll head to the tasks part. Here we have a unified task view. The admin can see the tasks that require assignment and decide which team should handle them. For example, this task can be assigned to the maintenance, operations, and station manager, depending on what the situation requires. If we assign it to the maintenance part, the task is removed from the admin's pending queue and is routed directly to the appropriate team's dashboard. They can work on it and updates its progress, but they don't have the authority to assign it further. So the idea is simple. Admin controls and coordinates, while each operation role only focuses on the work assigned to them. Now, Padu will explain our technical architecture, AI orchestration, and how we implemented the intelligence behind this workflow.
I am Ashwin, backend engineer. Now coming to my part, I work mainly on the backend and alert system of RailMind. The main idea behind our backend is simple. The front end should never be the source of truth. Every important operation in RailMind is handled through our backend APIs and stored persistently. We built the backend using FastAPI with Python. FastAPI acts as a communication layer between our dashboard, database, and the different components of the RailMind system. It handles things like authentication, task management, employee operations, incident updates, and real-time communication. For data persistence, we use MongoDB. This allows us to maintain important information such as incidents, department tasks, and operational updates even when the dashboard is refreshed or restarts. We also implemented JWT based authentication so that access to the system is controlled through authenticated users and their roles. This is especially important in a railway environment because not every person should have access to every operation. For example, when an incident is detected, the backend doesn't simply display it on the screen. The incident can be processed, stored, assigned to the appropriate department, and its status can be updated through the backend. The second major part I work on is the alert system. In a railway emergency, showing an alert only on the dashboard may not be enough. The responsible person may not be looking at the screen at the exact moment. So we integrated Twilio SMS into RailMind. When a critical situation, such as a severe speed warning or a major track delay, is identified, the system can trigger an SMS alert to the designated operational coordinator. This means the alert can reach the responsible person even outside the dashboard. So, in simple terms, my part ensures that RailMind doesn't just detect problems, It securely stores them, manages them through the backend, assigns the required actions, and communicates critical situations to the right people in real time. That gives RailMind a reliable backend foundation and, more importantly, makes our alert mechanism useful in an actual railway operational scenario. Thank you.
Now, let's look at what actually makes RailMind intelligent. A railway event by itself is only a piece of information. A delay, an abnormal movement, a disruption. The difficult part is understanding what that event means for the rest of the operation and deciding what should happen next. RailMind addresses this through a stateful intelligence and orchestration layer built with LandGraph. Uh, Instead of making a single AI call and blindly trusting the result, we break the operational reasoning into a controlled workflow. Then the event is first ingested, the system detects the anomaly and then evaluates its operational context, then predicts potential consequences, and then routes the situation with the appropriate reasoning and response paths, including reasoning, rerouting, coordination, and alerting. Then, at the reasoning stage, Gemini analyzes the structured operational context and generates a response based on the situation rather than simply generating a conversational answer. And this is where our architecture becomes important. We don't ask the language model to invent railway routes, calculate everything, or directly control the operation. For constrained decisions such as route alternatives, RailMind combines the AI layer with deterministic graph-based pathfinding over our railway network model. So what we are doing is we separate what AI is good at, understanding context, synthesizing information, and reasoning about consequences, from what software should control deterministically. And most importantly, the AI does not get the final authority. The AI proposes, the application orchestrates and then validates. Role based workflows route the resulting action to the responsible operational team. That gives us three layers working together: Gemini for contextual intelligence, deterministic algorithms for constrained computation, and LandGraph for stateful orchestration. So, RailMind isn't just an AI chatbot sitting on top of railway data. It transforms an operational event into a chain of reasoning, coordination, and action. That is the intelligence layer powering RailMind.